All right, welcome everyone to the virtual interim for OPSAWG. This is in lieu of a person meeting in Vancouver. We are on WebEx, and this is a recorded session. Bringing up my share here.
Are you showing the slides?
I am now. Hopefully you can see it.
I cannot. How about any other people?
Can anyone see the slides?
Yes. Yes.
Okay. Hopefully the lag will catch up. As I said, is the virtual interim for OPSAWG. This session is being recorded. If you've had difficulty joining with your computer, try the call-in option. Make sure video is off. Make sure you're muted unless you are speaking, just because there will be a lot of background noise. You have the ability to unmute yourself, but if there is background noise, we'll mute you. To join the mic line, just do a +Q in the WebEx chat. Make sure everyone is selected. And if you want to step out of the mic line, just do a -Q. The Jabber room is there, opsawg@jabber.ietf.org. I'm currently sharing and can't really monitor. Tianren is out there looking at the WebEx chat and the Jabber. But if anyone says something substantive in Jabber, just have them go over to the WebEx chat to join the mic line. There is a virtual blue sheet. I'll get to that in a second. There's a virtual blue sheet. I'll talk about that in a second. And we mentioned the Jabber room. This is an official IETF, so the note well does apply. I'm sure many of you, if not all of you, have seen it, but it is up here. Be aware that anything you say here, anything that you type, these things are being recorded, these things are being tracked, so the note well applies there. Tianren and I are your hosts today. We did the note well, the blue sheet, the virtual blue sheet. If you go to that Etherpad link there in the minutes section there, you'll scroll all the way down to the bottom past the agenda. You'll see a register, a blue sheet register, where you can add your name and affiliation. We're not really going to have a Jabber scribe, like I said, in meetings, these other virtual meetings I've attended. It's mainly been used as a side channel. If anyone wants to record something, just come cue yourself. If you can't, for whatever reason, Tianren will look, or anyone there in the Jabber room can act as a proxy, or just let me know that there's something there, and I'm logged in as well. I can get out of this and go look at that. The slides are posted at that link there. We will be going through them here, obviously, and we're all on the WebEx channel or WebEx meeting, but you can see the link there as well. In terms of the agenda, we have the current status of our documents, and then we have, of course, a number of presentations. Good news is TechX, the authors have closed all the discusses, and the document is moving forward. Warren pushed that through, so I want to thank the working group, the authors, who I don't believe are on today, for all the work and getting that forward. Because of that, the Yang TechX draft, or TechX Yang module draft, we think is fairly stable. We'll do a working group last call after this. Network telemetry framework, they've incorporated recent feedback from Adrian Farrell, and they also think it's ready for a last call, so we can push that out there. The SDI, the secure device onboarding work that Warren and Colin were working on, Michael Richardson did a shepherd write-up of that. And then now we're getting all this additional feedback from Tom. Michael's also chiming in there. So there's been some revision to that, and there likely be some more before it's finally submitted to the IESG for further work. We put out a sector request for review. We didn't get one there, but regardless, when if we don't get something on the security side when it goes through the ADs, and Warren has also reached out to an AD look it over. It will get eyes on. The L3SM, L3NM, and the automation framework, those are going to be presented today. Anything else to add on this, Tianren?
Great.
Okay. So the other thing we've added is a OPSAWG GitHub organization. We've got 2 documents being worked there. If just like any other GitHub organization for a working group, if their desire to move a project there, let Tianren and I know, and we can add you as members. This is, of course, you don't have to be a member to contribute. You can go here now and look at these projects. If you want to use them for issue tracking, for obviously the version control, by all means, we have that set up now. And we have some boilerplate kind of Notewell markdown that you can use as well if you're interested in moving a project there. In terms of the presentations, we front-loaded with some of the working group items, the things that have already been adopted. We saw that 2 of them will be presented today. So you see the layer 3 in the network automation framework. Then we kind of group things together where they fit. We've got some additional related to the L3 work there. We've got the MUD hour right in the middle. Sampled traffic streaming. We heard from Andrew last time, but we'll hear again. Then we have IFIT, we have Benoit. Unfortunately, he's under the weather. I'm with some notes from him. We'll present that, and we'll finish out with something that was initially AD sponsored, but requires some more eyes on, I think, and that's that IPFix packet sampling protocol and bulk data export work. There are some additional drafts if we have time. This is a packed agenda. If we have time, there are 2 others. It's in the agenda on the Etherpad. We might get to it, but knowing history, we probably won't. I asked the authors, the presenters, please be cognizant of your time slots and do your best to fit in that. And finally, we'll move over to Ops area. There is some open mic time. With that, are there any questions on the agenda? Excellent. I would also like to say that we have a new Ops AD in Rob Wilton. He's joined us, he's on the call. Welcome, Rob. Thank you for stepping up to be the Ops Management, I believe, AD. And I'm sure you will have a more formal introduction in the Ops area section, but I'm very glad you and Warren are both here joining us this morning, evening, or afternoon. With that, let's get our first presenter queued up. Hopefully you're all still seeing this. And I believe, Chin, you are presenting. I will do the needful with the next slide. So please unmute yourself, Chin Wu, and take it away. Assuming he's here. I don't see him. Oh, there he is. Chin, are you there? Can anyone hear me?
Yep.
Thank you. Let me see if Chin
No problem.
the list.
Yeah. I don't see a mic against his name.
I did. He's got his headphone icon there.
Headphones, yeah.
I see him.
Well, he seems to be having audio issues. He muted and unmuted. Give him a minute, and I will ask if he can't get situated quickly. Oscar, would you be willing to go, and we can just flip you two around?
Yeah, yes. I can start the next presentation while Chin solves his problems.
So Chin, if you can hear us, we're going to do that. We're going to let Oscar do his first, get back to you, and then we'll flip back to Oscar. So with that slight agenda bash here, Oscar, take it away.
Okay, thank you very much, guys. And let me know if there is any, you can hear me properly?
Yes, we can. You sound great. Thanks.
Okay, perfect. So I'm going to present you today the updates of the Layer 3 VPN network YAN model. Just to just go to the next slide, please. So I'm going to tell you which are the updates from the 0.1 version, which is the last one that was presented in the last IETF meeting. Now we are in the 0.3 version. We submitted one version last week. There were some issues to close that we did not have time when submitting the 0.2 version. So so there we have the 0.3 now. So then after this set of update, I'm going to tell you going to some specific sessions where we had or some parts of the draft that we had more advances, the multicast, the auto assignment, which was one of the open issues in the last one, and also highlight one of the collaborations that we had with TIAS for the service mappings, and then go to the next steps. So please go to the next slide. So which are the changes? So first of all, we have some new contributors. So we have Lucia, Manolo, and Erez. So they have done great contributions. So especially the L3, the multicast L3 VPN was completed. Then also we have many new insights and refinements thanks to the contributions. So now I think the document is quite good. So we have as you mentioned earlier, we have the official L3NM repository in the OPSAWG working group repository GitHub group. So here you can go there, check all the issues, all the pull requests that people have been contributing, all the commits. So here we have 38 issues closed, and each of these issues have been discussed in the calls that we make regularly, or either in the mails, or sometimes the discussion. You can see it there, the discussion in the JIT. I encourage guys to always to try to leave there the comments, contributing and commenting in the GitHub is like contributing on the mailing list. Okay, so it stays there. So you see that there was a lot of activity with 264 commits. So it's been quite active, this one. So regarding the changes themselves, so as I mentioned, the multicast support was completely was revised and updated, and we validated against the real use case. So it was the IPTV multicast of Telefonica based on L3 VPN. So we tested that everything, at least against a real use case, was needed. Then there was some request to support some more complex import and export profiles. So we added the possibility to create and/or operations between communities. So for example, 2 targets or 2 other targets shown in the example. So now this is possible to add it in the to request that through the model. Also, we had an issue with how to identify the VPN network access. Just to remind you that the VPN network access is the point that enters the traffic into the VPN. So there we added the port ID to clearly identify which is the interface or sub-interface in a topology. Previously, we had just the VPN network access ID with just an ID. So I think separating the concept is much better. So also we checked a lot. We had a lot of requests coming from the many operations requesting to be able to express through the model some BGP parameters. So just remind that this is not a device model, so we wanted to be able to pass through the network model only those BGP parameters that are essential and they have real operational needs. Also, we added one additional CEP routing protocol, ISIS, because we identified one use case that a request from an operation that required it. So next slide, please.
Before I do that, I put myself in the queue. You mentioned that you're tracking issues in GitHub, and that's fine. But this is a working group document, and I would ask that if there are any decisions, anything that you need working group consensus buy-in on, that the list is the canonical place to go. So please be sure you're taking those things to the list. The GitHub isn't a replacement for that. It's great for working collaboratively, but some of those things do need to come back so the working group has visibility into that work that's happening.
Okay, so then let me do the following after the meeting. Let me try to get all the discussions, main discussions there to the list, taking them from a summary of each of the discussions that happened in the JIT and that drove to a decision.
Okay.
So people can work on it. Okay, perfect.
Okay, thanks.
So then we had solved the auto-assignment issue that we had in the last IETF. This one, we solved it querying through the mailing list. So here, as I'm going to explain later, we made the RT assignment optional. Previously, it was mandatory, so that is now changed. And we added a way to express some preferences on the underlay. So we can so the operator or the service orchestration layer can indicate its preferences. So if you want LDP, if you prefer SVPT tunnels, if you prefer cement routing, etc. But the service mapping itself, for example, if you need to map to tunnels, is done in a document with the TS. So also we did some minor changes, like in the VPN node only have the network element ID as a key. So for each node in the network, you can have only one VPN node for that particular VPN. And we clarified, as requested in the last IETF meeting, the relations with other YANG modules, so especially with L3SM, which are the relations. Even we added a pointer to a reference to the L3SM, so you can match. So you can, if a service has been triggered because of an L3SM request, the pointer to the L3SM ID is added. And also we added a list of potential service modules that can be used. Also, we cleaned the YANG module. Please go to the next slide. And we reviewed the test, and we added some samples of the use of L3NM. We added some examples, and also we added one more implementation by SE Telecom that contacted us. So we know that there are more implementations around, so just including them is a matter of the management approval and so on. So in sake of time, please go to the next slide. I'll try to be quick. So in the BGP parameters that we added, so we had a request to add, we reviewed, these are the ones that finally were chosen to be added to the module, so the BGP description. So people wanted to express there which is the string that will go and pass down later. So it facilitates the troubleshooting, the administrative and operational status, so to check the health of the pitching session directly from the L3NM, the local autonomous system, so you can override the autonomous system. We have seen use cases in reality while the VPN has one AS and what you show to the customer is another different AS, so here you can overwrite it. And in the security, allow the encryption in the BGP CEP session. Please go to the next slide. Also, we, as mentioned, we had a lot of work to finalize support of multicast. So we updated the multicast container, which is managed at the VPN node level now. We added an anycast container. We added a couple of leads, the local address, which identifies the IP address of the local render point. Also, we added a set of RP addresses, so these are all the IP addresses from all the routers that set the same render was point. We modified the name to clarify the name because we had a parameter called the single address. However, it was not quite full, so now we change it to group prefix, which is much clear the role of that parameter, and added the MSDP protocol container. So with the several leaves, so if it's enabled or not the protocol, the peer, the local address, so to configure the multi-source tree discovery protocol. And we added also, and we removed the customer tree flavor container. And for each of the accesses, we added the remote source leaf. So we can go to the next slide because I think we don't have much time. So the auto assignment, we had 3 possible behaviors that then
we need to control your time.
Okay, yes. So I think this was discussed in the mailing list. We queried netmod for guidance. So finally, we included a solution proposed on this feedback. So include explicitly in the description of the junk the behavior that if it's no leaf is created, the entity must have auto-assign a value, and that in the value itself include an empty type that means that you don't want any value to be assigned. So please go to the next slide. This is a joint work with IAS for the service mapping. So it's to be able to identify which are the set of LSPs or virtual network or tunnels that are associated to a given service. So here you have the reference, and I guess it will be presented on TIAS. It's a collaboration with TIAS. So go to the next slide, and I finalize the presentation. So we now, after all the changes and discussions among all the authors, we think now that the young modules is stable. So we are now in, we believe that we can go for the young doctor review. So we think that there won't be any major changes now in the structure and so on. So just some tweaking in the text might be needed just to finalize even there are some points that might not be clear and so on. We can work on that. And we ask the working group to review this version of the document, so we can go and finalize it in a couple of months. Okay. So that's all. Thank you.
Questions for Oscar? See anyone coming in the queue? I noted your Yang Doctor review. We can get that put in for you after this, and we talked about just those decisions, those kind of what you need the working group to weigh in on, especially because you're asking for the review. Just summarize that from GitHub, please. Okay. So you're still on deck, but Chin has told me he's back. Chin, can you hear me? We can't hear you, Chin. Oh, are you calling user 5?
I call through the phone. Can you hear me?
Chin, is that we can hear you now? Okay, so I'm going to put your presentation back up.
Yeah, sorry. Okay.
Your presentation back up here, and can you? Hopefully, you can see because it's going to be kind of hard to present if you can't. Okay, take it away then.
Yes, I can. Yeah. Thank you.
Chin
Sorry
Wu.
about that. Actually, I got a trouble to join. Yeah, I can hear you. Hello.
Yeah,
Yes.
sound fine.
Can you hear me?
Yes.
Yes.
Yeah.
Go ahead.
Oh, okay. Maybe that's okay. So this just talk about a young model automation framework, and I'm here to present this. And this actually is a joint work with many operators. And the name we list here are also this draft. Next. Yeah. For people who don't know what this job is talking about, actually, the target audience for this job is operator and young model developers and implementers. And I think the big challenge faced by the operator when they deploy young data model at a different layer is how this model put together to provide service delivery and to realize the service fulfillment. So this draft really provides guidance to show how this model put together for service fulfillment and service delivery. And the architecture we propose in this draft, we identify the common functionality that can be used by multiple models. This can help to build the fully YANG-based system. So also we actually give several examples to show how this common functionality can be used, where they can be used. Next. So what is the current status of this draft? This draft has already been adopted by the OPSAWG since last Singapore meeting, but this draft has been around for a while, and this outcome of the YANG study meeting in last year, actually. The changes were made since last version. Actually, we try to address the comments raised in last Singapore meeting. One of the comments from Lauren, actually, what he suggests actually is to move service decommission from the network level to the service level. So we try to address this. Also, we got comments from Diego actually to try to clarify the service verification. The position actually clarify the relationship between the service verification and service creation and modification. In addition, actually, we add a new figure, try to add more details about service attribute and clean up the reference. And we also add a new use cases for the event-based telemetry automation. And yeah. Also, we try to complete the security section and make it more complete. Yeah, next. So model layering and representation. Compared with the previous version, actually, we add more details about service attribute that be defined in the service requirements. Actually, this service attribute can be classified as several categories. For example, connectivity, flow identification, traffic acceleration, routing and forwarding, etc. And for other part, actually, it's the same as the previous we proposed. Next. This is architecture for the service and network management automation. Actually, based on the comments from Lauren, actually, we actually move the service decommission to the service layer. In addition, actually, we add one bottom-up feedback from the network orchestrator to the service orchestrator. We can provide service assurance notification. And for other actually important part like multi-layer, multi-domain service mapping and domain-specific service decomposition, actually same as we proposed before. Next. Okay. So the change we made, actually, this is a use case we proposed in this draft. It talk about the L3 VPN service delivery. We use L3 SM, L2 NM as an example to here, actually, we just provide a top-down service delivery. But what is missing, actually, is when you get a service deployed by the operator, so operator also care about whether service get deployed successfully. Another case is when you get a service set up or get a network set up, you really need to care about what does the network performance look like, actually. So it lacks the feedback from lower layer to the upper layer. In this version, we add the feedback from from the controller to the orchestrator. Also add the feedback from the orchestrator to the customer. Next slide. So this feedback, we call the L3NM notification or capability exposure, actually. And on top of the orchestrator, we also add the notification. All of these feedback or notification can be used for many purposes. One of the purposes actually can be used for the billing or accounting, actually. So this also very important to provide the service assurance, build the closed loop management. Next. So this is the 3 use cases that we're proposing in this draft. Actually, the first 2 cases, as I clarified, we added the missing piece, added feedback in the first cases about S3 VPN service delivery. For the second case, we don't make any change actually, but also it can provide service assurance using the performance measurement and telemetry model. And also we added the third cases we can support event-based telemetry automation. The idea is, you can dedicate a network control logic to the device and populate the policy from the controller to the device, so device can provide device self management, provide a quick response to the events actually. And so this change we made actually. This case actually also can build the closed loop management within the device. Next. So we think this draft reaches completion. Actually, what is the missing piece is about service assurance. Actually, we already added the notification capability exposure from the lower layer to the upper layer. And talking with our cursor and editor, and we think maybe we consider to add another example to show how this service assurance can be performed. So we would like to hear more comments raised in this meeting, and we hope we can request working with last call in June to get this work done. That's all. Thank you. Comments and suggestions, feedback.
Yeah, Qin. This is Tianran. Yeah, you mentioned the service assurance and BI many times in the slides. Is there any connection to the work the Benoit proposed that we'll present later?
Yeah, there's some connection. I think the service assurance architecture proposed by Benoit actually provide more, abstract architecture. What he need is, you do the translation between the technology independent metric, performance metric, to the technology specific performance metric. In our architecture we proposed actually, we can leverage young data model and also young push telemetry mechanism to develop some loss bounding based performance measurement model to aggregate the performance metric. And this is more, connect the metric from the underlying network. So what he proposed actually seems, build the overlay architecture. But they may rely on the metric translation or metric engine to do the translation between, the technology independent metric and technology specific metric. Yeah, that's something relation between two work.
Okay. Is there any other comments?
I would say that on what you have up here, Chin, about adding another example and comments raised in the meeting, if you've got specific questions of the working group, what example you might want to add, I would just bring that back to the list to get more people looking at it and more input ahead of any last calls. Are there any additional expert reviews you want at this point, like an early review in this document?
Yeah, I'm not sure we can request a young doctor review, but this is just architectural draft. Maybe nothing young doctor can do about it. And but for the example, I will talk with my cursor, Matt actually about this example and bring back to the list when we come when we sort out this kind of example. Yeah, sure.
Thank you. I would, I put it in the chat, but I'm going to say it again. If you haven't filled in your name in the virtual blue sheet in the Etherpad, please do so. The link is a lot of places. It's also in the WebEx chat window. Thank you, Chin. Oscar, we're going to move back to you.
So this time it was 5 minutes, right?
Yep. And back to Oscar Gonzalez Diaz.
Okay, thank you very much. So now, before we presented the layer 3 VPN network model, now we received similar requests to do the same work for layer 2. So this is precisely the doing that, particularly for layer 2 VPN. So go to the next slide, please. So what is the motivation? So we already have a L2SM model that captures the VPN service from the client point of view. So in order to deliver the service, we needed this more network-centric view that takes or digs more into the network details. So we have this new module, this L2NM. This is a young module to manage this provisioning of the layer 2 VPN service in the service provider network scope. So we can use it also to derive the configuration, the detailed configuration of the devices and the underlying transport that you need. Okay, so please go to the next slide. I don't have much time. So what is we try to maintain the same module structure as in L3 VPN. So in some cases you might not need all the information. So depend, because this module aims to cover all the different types of L2 VPNs. Okay, so but the concept is the same. We have everything pivots around the VPN service. So the YAML module contains the list of VPN service in the service provider network managed by that controller that has VPN nodes in all the points that you want to have connections to the VPN, and you have VPN network accesses. That is where the traffic comes. So the relation is 1 to n or 0 to n, 0 to n. Okay, so please next slide. So we applied inside the service provider network, so that is between PEs, so that is the border of the VPN or the L2NM scope. Here we need to support point-to-multipoint, point-to-point, and multipoint-to-multipoint services, and also be able to select which is the underlying transport that you want, whether it is IP MPLS, whether it is BGP, segment routing. We also want to express that preference in the model. So please, next slide. So here is the main slide. Okay, so which are the highlights of the module? So we started from what was existing in 2SM, and we added the pieces that were needed to fit the network view. So for example, support new service types. For example, eVPN. So here I think there is a lot of work now in BES for doing the device modules to support eVPN. So I think this is the piece that fits in the middle. Supports all the legacy access technologies. So we need to support Ethernet, circuit emulation, etc. So we have many kind of accesses. As mentioned before, requesting the underlay transport protocol preference, so whether we want BGP, whether we want LDP, segment routing TE, etc. Support redundancy, so we have remote terminations. Support some parameters of, for example, the target route distinguisher for the BGP VPLS, and support the administrative and operation status. So these are the main additions of the module. So next slide, please. So if you want to contribute now, we have in a private JIT, we are using the same procedure, track issues, and receive comments. Also, please use the list, also not to, sometimes they compete, the JIT and the list. There are some issues that are discussed to improve the model. For example, the service mapping, we have already done a collaboration with with TIAs also to include this L2 mapping there. And also we have also some some implementations on the way. So go to the next slide, please, and then we finalize. So here we request the working group to review this document to see if it's useful, see any flaws, anything that you want to add. So we want to fix these issues and comments from the reviews. And if at some point you think it's worth working as a working group and not just an individual, it also would be great. Okay, and with this, I finalize the L2M presentation. Thank you very much.
We have two people in the queue. Jinbin Li, you're first.
Okay, Oscar, can you hear me? Oscar, I have the two questions. The first question is, I see that you have the open issues for the EVPN support. I'm not sure if the EVPN is not supported in this draft, or just some cases of EVPN are not supported by this draft.
I think we started to add the EVPN support. I think we added it in the last version of the draft. So now it is supported. I think it was in L2SM where it was not supported. But maybe what we need to check if all the parameters that are required for later triggering the EVPN device models are available or not. So that work of reviewing all the EVPN support is needed. So right now it's just a type. So you can request an EVPN type. Okay, so there is work to do.
Okay, I see. The second question is that I see that the L2 VPN, most of the L2 VPN features are supported. I want to know, because the L2 VPN is a little complex, I want to know for the HVPRs, I mean, the hierarchical L2 VPN can be supported by this service model or not?
I would say yes, but I don't know whether I will need to review whether everything needed is there or not. We will need to review it.
Okay, so how about the inter-AS scenario? Inter-AS L2 VPN.
Yeah. I think yes, but maybe some of the co-authors can also want to. If some of the co-authors want to answer.
Yes. Hello. Can you hear me?
Yeah.
This is Samir here. The inter-IES scenario is one of the use cases that we have been planning to support. Currently in the model, we support the selection of the transport protocol or the underlay transport protocol. So inter-IES option C was the target use case that we were expecting to solve. So in this case, we could select BGP as the transport protocol, and we can configure or assign also the remote address of the termination point of the VPLS. So in this case, the inter-IES deployment is supported. However, we are still enhancing the set of network parameters that we require for the hierarchical VPLS, for example, and other use cases that we have in our network.
In the interest of time, I think this is a discussion for the list, especially since you're looking to get that feedback. I'd like to go to the next person in the mic line, to Italo Busi, so we can clear this out. So please take this conversation to the list. Italo.
Thank you, Oscar. There is another draft in CCAMP working group, which is addressing a similar problem. It's mainly focusing on traffic engineering, so there may be missing pieces, but there is a lot of overlapping apparently between this draft and the CCAMP working group draft. Have you considered that and the relationship between these two documents?
Which is the document that you are referring? Can you point the or type the reference?
The client signals model.
I think that the client signal model was more aimed at the pure transport part, right? Not Ethernet VPNs. We need to check out if there are any potential overlaps.
There are Ethernet services that can be supported over transport, and they are also covered by that draft. Yeah. Okay, we can talk about that.
Okay.
And Rob.
Yes. So, can you hear me okay, Joe?
You're a little tinny, but you're clear.
More or less.
So my question is more a meta question here. So we've got two examples of network YANG models here. IETF has lots of deviceable YANG models. I'm trying to understand is how much work is there in the general area of network-wide YANG models? Is it just going to be an L3 and L2, maybe an L1 network model, or is there going to be extra models for covering various features from a network-wide perspective? So my question to the authors and maybe to the working group is, how much work is there in this general area? Is this something that we should be focusing separate working group perhaps on this area, or is having an OPSAWG the correct place? Do the authors have a thought on that?
Yeah, or right now, or the kind of services that we were started to focus in were on these two because they were the ones that were more popular in our network. So they say from network operator perspective, those are the ones today. So should new services appear, okay, we would expand it. But for now, as I think as pointed out correctly in Chin's presentation, there are, regarding these two main services or network-wide services that are presented today, there are gaps around it. So with these two drafts, we are focusing on some specific, just the provisioning part. So we think we need to solve or to work on solving gaps around that more than right now in our view to add more services. So if there are more services that required by operators, of course, there will be more work. But for now, service-wide perspective, those two are the ones that are, I think, for us as operators, we see okay.
Okay, thank you.
So it sounds like for now the scope is fairly limited or restricted at least, and it fits where it is. But it sounds like if there are going to be a proliferation of this, maybe that question could be revisited. That's how I heard it.
Yeah.
Okay. That clears the line. Thank you very much, Oscar.
Thank you.
Next up, we have Med Bukader on the YANG model for user network interface topologies. Med, can you hear us? Take it away.
Thank you, Joe. Yes, so this presentation will be about the user network interface. So this will be, I would say, a natural continuation of the two models that were presented by Oscar, the one about the L3NM and the L2NM. And actually, we decided to edit this draft as a separate one because there is I would say, it's not specific to a given service, but it can apply to multiple services. So if you can to the next slide, please. So basically, I would just describe the issue why we need this kind of models. Then to present you, I would say, briefly the overall structure, and then to discuss some next steps from the drive. So if you can move to the next slide, please. So this is just, I would say, a simple view of the, I would say, of just a network in which we have multiple customers. Each of these customers have their own sites, and these sites, they are connected to services that are delivered by a given provider. So each of these customers has its own view of the service which is provided by I would say, by the network, as can be shown in the next slide. For instance, if we focus on the, I would say, on the block customer, what it sees, it sees, the next slide, please. What it will see, I would say, a topology in which it has its customer, the each devices that are interconnected and they have connectivity by some magic, which is provided by, I would say, by the network provider, and sometimes by multiple providers, and all what it sees is this topology. But now, if we go down to the network provider, as we can see in the next slide, we will have, I would say, we will see at the service level, which is, I would say, the ISM. Which provide, I would say, an abstraction of the service which is provided to these customers to these multiple, I would say, sites. All what we see the, I would say, an interconnection of sites. We don't even have the devices. And then when we translate the L3SM service model into the L3 network model, as can be shown in the next slide, we will see right now that the service, so we have the same service, but we have multiple views. And now what we have only the, I would say, the interconnection between the provider edge routers, and there's this topology which is only shown and maintained by a network controller. So there is something which is really missing here. If we want to have the gap between the service which has seen by the customer as the service as perceived and seen by the network provider, we have something which is really missing. In the next slide, please, which is where to deliver the service. And this can be answered by including, by defining or by including a reference into the interfaces that will be shown in the next slide, that we call the user network interfaces. So these reference points are important to have the gap between, I would say, the overall service which should be provided and delivered to a customer and the current view we have at the network level. So if we enrich the information which is provided at the L3 NM, I would say, level with the various reference points that are pointing to the interfaces that are used to deliver the service, we will have something which is more rich, so that in the next slide, for instance, we will see that the network controller now has, I would say, the a holistic view on all the, I would say, the point in which it can deliver the service. So the network topology we have today in that are defined in various models in the IETF can be enriched with this information about the user network interface, with a focus on the, I would say, on the provider side. We don't focus on the customer side because we already the current topology models already provide this kind of views. So if you can move to the next slide, please. We will see that this is the I would say the simplified, I would say, the model of the user network interface. So we are adding this service attachment points with identifiers and also with more information about the encapsulation type that can be enabled on our per interface. Next slide, please. So for this model, we could decide to have this, I would say, this structure included in the L3NM draft that we have already adopted in OPSAWG working group. But the point is that this kind of, I would say, information is not specific to a given service, and it can be reused by other services or models, for instance, the layer 2 network models and so on. So it's not really specific to a service. So what we know what we would like to hear from the working group is a direction for this work, whether we maintain it as a separate or we can just maintain it on the one of the current models and that are already presented by Oscar, for instance, the layer 2 NM or into the layer 3 network model. That's my presentation.
Thanks, Med. Italo Busi is in line. The mic.
Yes, thank you. A similar comment to the previous one. We have a similar draft yet adopted as working group in CCamp because we have exactly the same problem when we set up a client service over a transport network. It's that you need to know the UNIs, which I agree is generic, but also you need to know I know some boxes are, for example, in layer 2 are able to do VLAN classification. Some are based on 1, some are based on 2, some are not based, are just doing Ethernet frame-based mapping. So the UNI discovery is something generic, but the capability are specific, and we have some work already in SICAM, so I think we need to reconcile a little bit the solutions.
Yeah, please just send us a pointer to your document, and let's work together on pushing this forward.
Fine. Yeah, good. Thank you.
Yeah, and I have I have a clarification question. What's the type of this kind of model? I mean, the service model or network model or device model?
This one is for me, it's I would say a topology model, which will augment the current, I would say, the current network topology, which is already, I would say, specified in existing RFCs. Yeah.
I mean, who will consume this model?
The network control, network controllers.
L2NM, L2NM, L3NM, or L3SM.
All of them can consume that model.
All of them can consume this model. Yeah. What's the abstraction layer? Because right now there are several kinds of models. The service models were abstracted, and also the network model, like L2NM, and the device model for devices. So it could be used for all of them.
This is Oscar. If we go for the Chin Wu's presentation at the beginning with the network control layer and the service orchestration layer, I think this is a topology view that can be exposed by the network controller to the service orchestration layer, telling from which points can service be instantiated. So then the service orchestration layer can use either the L3NM or the L2NM to request the desired services in the potential endpoints that were shown by the UNI topology.
Okay, can I see this is a new kind of service abstraction? And maybe in that framework document could describe this kind of things. Okay, that's fine. Chin, are you going to explain or ask questions?
Oh, yeah, sorry, I have to unmute call-in user 5 here. Chin, go ahead. Chin, can you hear us? We cannot hear you.
He's muted, I think.
I unmuted him.
It appears, at least in my screen, he appears.
Hello,
muted.
hello. Can you hear me?
Yes.
Yeah, can you hear me?
Yes, please.
Oh, sorry. I'm muted. A simple answer to the Tianran's question. Actually, UNI topology model is a network level model, similar to the network topology model that has already been published, actually, as Mohammed clarified. So, yeah, we can show this UNI topology usage in the Young model automation framework draft. Yeah.
Good.
Does this answer your question?
Yes. And next, Rob.
Okay, thank you.
I just trying to understand how these fit together. You're saying it complements both the L2NM and L3NM models. I don't know how they fit together. Is the expectation then that this would augment both of those Yang models, or does there need to be an underlying generic network model that both that this augments, and so does L2 and L3NM? So I'm just questioning how all these different Yang models are meant to fit together the network.
This is actually shown in the previous slide. Yeah. If you can just move. This is when we describe what we call I would say the previous one, please. Previous one. Thank you. So here, when we see what you see, the L3NM, which is, I would say, covering the scope, which is only between, I would say, the provider edge routers themselves. This is what covers by the L3NM. And then when we add this, I would say, the unite to topology, we include this, I would say, this missing piece, which is the demarcation point between the P and the C router. So that's why we on purpose say that we are the two models will complement each other to provide the overall, to deliver the overall service, which can be modeled in another service. So the complementary here is in matter of, I would say, in matter of scope of the network scope. The user network interface is really what it said in the name. This is really specific to the demarcation point between the P router and the C routers. And the existing, I would say, the L3NM or L2NM will just cover, I would say, the PM between the various devices themselves that are including the, I would say, the equipment provided by the network provider. So it's a matter of scope. That means that we have multiple scopes. One of them is really specific, I would say, to specific legs in the overall architecture.
Okay. I think I still in my mind, I don't have a clear, I'll need to read the drafts on how these things fit together, as to whether you're augmenting or you're expecting yours to sit alongside. But I'd have thought there needs to be some bindings between the L2NM model and the L3NM model and your uni model.
That's in the list, I guess.
Yeah, thank you.
Thank you very much. All right, next up, Tiru. You ready? Can you hear us?
Yes, I can hear you. Can you hear me?
Yeah.
Hey, great, thanks.
Take it away.
Hello. Yeah. Hello, everyone. I'm Thiru. I'll present updates to MUD TLS profiles for IoT devices. Next slide, please. We will go over a quick recap and then the updates to the draft and questions and comments. Next slide, please. Just a reminder of this draft. This draft was presented at IETF several times. This draft proposes to extend MUD to describe TLS interactions. It offers several benefits. Some of the ones are listed in the slides. The first one is the ability to define TLS profiles for IoT devices that have diverse communication patterns. It's useful for IoT devices that learn new skills and frequently change their communication patterns. It's also helpful for identifying MITM attacks, especially for IoT devices which have vulnerable SSL implementation, for instance, identifying inadequacies in certificate validation. Next slide, please. So what we have done to validate what we are proposing is we have profiled several IoT devices, basically the home network IoT devices. What we observed was that the TLS profiles for IoT devices for benign flows was quite different from the TLS profiles for thousands of malware flows that we got from our research lab. And the conclusion is malicious DTLS use can be successfully identified and blocked. And one of the most interesting one was the TLS profiles for IoT devices, even based on type, manufacturer, and model, are quite different. Next slide, please. The updates we have done in the last couple of revisions is to highlight the growing trend of malware using TLS. And to also discuss the implications of TLS 1.3, which encrypts most of the handshake, but still allows inspection of several parameters, for instance, cipher suits and extensions, supported versions, named groups, and signature algorithms. Even the selected cipher suit in the server hello message can be inspected by middle boxes like firewall or IPS. What we identified was several malware could be detected even for TLS 1.3, even without acting as a TLS proxy. For instance, we were able to successfully identify malware which was using cipher suit randomization in client hello messages. Next slide, please. We also updated the draft to discuss the scenario where a firewall or IPS needs to act as a TLS proxy to do a full handshake inspection. And this section has been updated to reflect that the middle box has to follow the behavior defined in TLS 1.3 specification. TLS proxy may not be a viable option in several networks, but could be a viable option in IT managed for IT managed IoT devices. The advantage of this proposed mechanism is there is no need for the middle box to inspect the payload, and the middle box can be configured to skip connections destined to specific services due to privacy compliance requirements. As far as the analysis goes, what we identified that malware agents, it's quite impossible for malware agents to mimic the behavior of thousands of unique TLS profiles that we've seen from IoT devices, and it's going to be nearly impossible for them to keep up with the updates to the TLS profiles. Next slide, please. To address the comments from working group, we updated the Yang model to define the client TLS profiles once and reuse it. For instance, the TLS profile can be defined for a specific destination. For example, IoT device reaching a firmware server which is using a private CA. So that way, if the IoT device is using a CA for specific destinations, that can be defined in the client TLS profile. Next slide, please. We would like more feedback on this draft, and we would like to collaborate on profiling malware and benign flows from IoT devices, and would request for working group adoption of the draft.
Comments? Tianren.
Right now, I want to know what's the security considerations on the mod. I mean, the RFC 8520. Is that enough? And I think that will help you describe the motivation on this work.
Yes, we are referring MUD as a base Yang model and extending on that. MUD definitely helps to identify and define the intended behavior for devices which are headless and have specific communication. But when it comes to devices which have broad communication patterns, MUD is not that helpful. So this draft comes in play and is useful for such kind of IoT devices.
Does MUD provide any security mechanisms itself?
The MUD profile itself will be provided by the MUD TLS will be provided by the manufacturer itself, just like the MUD the specification that was previously defined.
Any other comments? Has been discussion on your draft on the list, and I know that Michael's going to present a few MUD-related works. It might be interesting to see how we want, as a working group, want to progress all of the next level of MUD work. And maybe the AD overall will have some comments on what we want to do with MUD in general. But I think, like you said, you presented this a number of times. It would be good to see what the temperature of the working group is if we want to start progressing some of this in addition to the base MUD spec.
Okay.
So it's worth. I'll take it to do to bring it up on the list. What we want to do as a working group around some of this work. So thank you very much, Drew.
Hey Joe, just can I ask a clarifying question for Tianren? I'm not sure that I quite.
Is that Elliot? Is that you?
Yes, this is Elliot. Sorry, I'm not sure I quite understood Tianren's point. Was it the in relation to this draft? Tianren, was it you wanted to know if the security considerations of RFC 8520 are sufficient for this draft, or that this draft outstretches those security considerations? Do you want to comment more? Because I think your point got missed, and I just would like to understand it a little better.
I mean, in MUD draft, I believe you have already there are some security considerations in that RFC, right? So is that is it to provide the already provide the security mechanism, or it's just describe the issues and describe the requirements, and this draft right now provides the actually the security mechanism.
Oh, I think, and perhaps Tiru can correct me if I'm wrong. I think this draft relies on the mechanisms and security aspects of the underlying MUD mechanisms, which are can be secure or less secure, depending on how you derive the URL, for instance. But I don't think this one introduces new security mechanisms to secure MUD, if that's the question you're asking.
Yeah, this draft does not define any new mechanisms for discovering the URL.
Okay.
Thank you. Let's bring up Michael. Michael, can you hear us?
Can. Thank you.
So
That's
15 minutes.
Yep, I'm gonna do it.
All you. Take it away,
Right,
Michael Richardson.
So one of the issues going forward is how we get the security for the URLs the devices provide. Next slide. So one of the questions is, why do you need to update the MUD URLs at all at any time? And there's one way to do it is you just update the MUD file in place. And another way is that you have the device, when it's updated in some way, provide a new URL. And there's some trade-offs, and the document goes into a fair bit about the difference. And one of the places where it turns out it's a better idea to replace the URL when you update the firmware is when you are using TLS profiles, is my opinion. And the reason is that if what you've done is you've changed your TLS libraries, then the profile is likely to be a bit different, particularly if you fix some bugs. And so you would like to go forward with the profile. But if you change the profile, you are going to, in the file, you're going to possibly make all the existing devices that have not yet upgraded invalid. And this is a problem. So the question is, if I want to update the MUD URLs, how do I do that? Next slide. So normally the MUD URL, next slide, comes through DHCP, next slide, or LLDP, and it gets to the MUD manager, and the MUD manager goes and retrieves it. There's a third way, next slide, which is that it can come through an IDEV ID, for instance, through Brewski, or there's maybe some other ways that you can use an IDEV ID to get a MUD URL. And that's considered to be the most secure mechanism because the manufacturers actually signed the IDEV ID. You actually can trust that this device, and the device has proved that it has the private key to the IDEV ID. So it actually has a very strong relationship to the MUD URL and the manufacturer. Next slide. So, but a malicious device with malware could put a different URL in the MUD or the LLDP. Next slide. And so it could, in fact, say, here's a malicious MUD file that lets me attack Facebook or its favorite target, and could basically make MUD useless. And so that's the problem, is how do I be sure that the MUD URL that I've been given is, in fact, legitimate MUD URL? Next slide. So the shape of the solution is that the first time you get the MUD URL, either by IDEV ID, or you might do trust on first use for the DHCP LLDP, and you get it. And next slide. You get it that way. You got it securely. Next slide. Sorry. Next slide. And so then we get the MUD URL the second time through DHCP. Next slide. Next slide. Next slide. I have too many animations, sorry. So then the restriction is that you can actually update the URL, but you'll notice it has to come from the same location. Okay, so that means that at most you could have a manufacturer, let's say LG, refrigerators could pretend to be their toasters. Is that a huge issue? Well, it may or may not be, depending on exactly how you organize it. Next slide. So people have asked, well, if the IDEF ID is more secure, why don't you just update that, and then you have no problem? And the answer is because you don't generally go through an onboarding process again after the device is onboarding, so you aren't going to use the IDEF ID again. And in many cases, you can't update the IDEF ID. It's in some kind of a TPM or other secure storage, and you really couldn't update it without effectively doing a factory recall of a product. And if you could update the IDEF ID, then maybe the malware could update it, and that may be a concern as well. Next slide. There's two ideas. One is that we update 8520 to essentially do a semantic change that says that the URL that you specified in it, the base that's inside the MUD file, in fact, tells you where updates have to come from. So that would be a semantic change to something that's already there. The second idea is that we add an extension to essentially provide a base URL. Next slide. And so then that's the question, what to do next. Questions? Or I could take them at the end if you prefer, Joe.
I don't see anyone in the queue, so why don't we keep going? If there are any, I'll give a second if there are any questions. Let's
go on.
What
are we doing next? The next one is
next one is going to be.
Hi, Joe. Elliot is in the queue.
Oh, sorry, Elliot is in the queue. Elliot.
Yeah. So thanks, Michael, for this draft, and I think it represents a good start. The key thing I think we want to think about is how might we protect against various downgrade attacks. So could we, for instance, have the original MUD URL have a forward pointer as to authorized MUD URLs? And so, or could the original MUD file have a forward pointer to valid MUD URLs for a particular device type based on say, versioning information or some such?
Yeah. So my proposal is that essentially that's option 2, is that you have a thing that says all future profiles must be prefixed by this URL, which lets you put a firmware version at the end, and that's really it.
Yeah. Okay. Sorry. Yes.
Okay. So this next thing is peripherally about MUD, but it's also about IoT and the great DNS over HTTPS and stuff. Next slide, please. So typical in a MUD file is that you will provide an access control list that allows a particular device. I have used Elliot's classic photocopier printer that we are suspicious about to access some service in the cloud. And I missed my air quotes. And the MUD manager will typically look up that service by name, will get an IP address, and install an access control list. Next slide. So, okay, so it gets more complicated. The service is now in a content distribution network. And so you're going to do a MUD manager, going to resolve something in the content distribution network. And if everything works well, you're going to install an access control list to there. So far, everything is fine. It doesn't look too much different. Next slide, please. So now the device manufacturers decide that they don't really trust the local DNS, and they're going to use some cloud-based DNS, whether it's DNS over, Quad X, or DNS over TLS, or DNS over HTTPS. It doesn't really matter exactly. What matters is that they're going to ask an external entity about this. Next slide, please. So next slide, please. Double in animation. So it gets back an answer. You notice it says 0, 2, 1, 2, 3, 4. You notice that's not the same answer the MUD manager got, which was 01, 78 AB. Next slide, please. So the connection that was authorized was to that near server, because that's the geographically closest device to the MUD manager. But the connection that the device makes, next slide, please, is some other place, which the MUD manager is like, oh, I don't know, I've never heard of this place. And it probably gets denied. So that's the fundamental problem that we're trying to deal with, is to make sure that this is not going to be a problem in going forward. Next slide, please. So there's some other problems that are related to this that show up, okay, where essentially the MUD manager is unable to see what the traffic actually was, and they're kind of related, and so I can clump them in the same place. One is if you have IP address literals in protocol, okay, go back to FTP, right? But typically that's the same location. It's not unusual to have some kind of protocol where the device asks the cloud, am I running the right piece of software? And if the cloud says no, then the cloud gives it a URL to go get the right piece of software. And if that URL that it gives it is not in the MUD file, because that was the whole point of asking the cloud, is they could now position it wherever they wanted to, use whatever cloud resources they needed to make the upgrade work, and then pass out whatever URLs they wanted. Well, that's not in the MUD file, and therefore that access is not going to be authorized. And another example is they have done that, but now they've specified, for instance, they may have said, well, Amazon S3 buckets typically have all the same name. So you said, I'm going to an Amazon S3 bucket. Well, now you can go to any S3 bucket at all. Next slide, please. So this document is about advice, essentially. Don't do this, all right? Here's a list of things you shouldn't do, okay? In particular, you should always use names within your own scope so that you always have control in them. You should always use DNS that's provided by the local DNS server so that you get the same geographic view of the rest of the thing. And if you are going to have some kind of content distribution network, then make sure that it answers with round robin DNS type of things. I think that's on the next slide. Always answer with all of the quad A and A records that you're going to use. And there's like the old way of doing this is with round robin was that they would just always rotate it such that the first IP address that is the one they want you to use, they would actually give you all the client all the rest of the IP addresses so that it could use them afterwards if it wanted to. I actually looked to figure out whether there was some BCP or some other document that explained how to do this, and it goes back, and I didn't really find a lot of IETF advice, and maybe there's some advice elsewhere on how to do this. But if you look up Google, for instance, or Facebook, they don't give you all the IP addresses for those. They give you a few, and you're expected to use that one. And if you happen to come across or have cached a different one, tough, right? So that's a big deal. And this is some advice that I think that we need to give to manufacturers such that when they are setting up their devices to use MUD, they pick the right thing. Next slide, please. And that's it. And so it's a BCP. Don't really have a lot of protocol parts. It would be, more examples would be good. Apparently the DNS people don't like the term quad X and didn't standardize it, so they don't know what we're going to call that. Questions?
Elliot.
Thanks for this draft, Michael. I think it's pretty important, and actually, just by way of how important it is, there's work going on at ICANN in the FSAC. I think Jacques is actually tied into that, by the way.
Okay.
That is looking at DNS for IoT. So a couple of points to make. The first of which is, I really believe that this is not fundamental to MUD, but is fundamental to IoT. That is to say, it's bigger than MUD, the problem that you're hitting on. Because even if you manually try to configure access lists without any MUD involved at all, you can still run into this problem if you cannot specify if you have no way to learn the mapping. The fundamental issue here is that the policy enforcement point for whether to decide whether to pass a packet or not is term, not well bound to the game resolution mechanism. Now, going back to one of the points that you've made, which is use the DHCP provided DNS server. In my opinion, I think that's good short-term advice. I'm not sure it's the right long-term approach. And so some of the other work that's going on in the IETF that has interested me along these lines, and should interest you even more, Michael, is that somebody has gone to the effort to parameterize in Yang all of the DHCP options.
Oh, yeah?
Yes. Now, what can you do with that? Right? One of the things you can do with that is you can provide those DHCP options over a secure transport. As in when you're enrolling or after you're enrolling. And I'll leave you to think about that for just a little bit. But so I would say this is an interesting work. I think it should become a BCP at some point. And we could even adopt it now, but I think it needs a little bit of work in terms of the advice being given.
So Tiro and some other people have been basically trying to make sure that it's possible to do DNS over TLS or DNS over HTTPS with the DHCP with the DNS servers that DHCP told you about. And I think that is very much needs to be what IoT devices do. Whether that's appropriate for your tablet, I may have a completely different view of that. But that's my view, is that IoT devices having no user interface need to use the local DNS, and because that's the only way that the local operator gets control over or can protect them if they really want to do DNS firewalls. And therefore, it's inappropriate for the devices to talk to the cloud for their DNS ever. And I think that would, I think if the document said only that may be very controversial, but at least you'd be able to ask vendors, are you compliant to RFC, blah, 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 and they would say yes or no. You'd know that up front. As for the comment about DHCP Yang options, that's an interesting way to make DHCP more secure, and that's interesting.
And I think Tiro's been looking at that too, so I know Tiro's had his hand up too. So.
Tiro? Here's Tiro.
Sorry, I was on mute. Hey, Michael, thanks for the draft, and I agree with most of the proposals that you have in draft. So what we have been doing is we are using domain names for doing DNS filtering for IoT devices for enforcing BERT. So that seemed like like the right technique, especially because of CDNs and geolocation and geo-proximity issues, that you could get different IP addresses. The other one is using IoT, not just for MUD, but I think IoT devices need to move to using DOT or DOH, not just for policy enforcement, but also for security and privacy reasons. You don't want people to see what DNS queries that IoT devices making, because we have seen many IoT devices making DNS queries, and you can pretty much figure out what that device is doing. So privacy is a very important aspect for IoT devices, and you don't want somebody to know whether you're talking to your Alexa and giving it commands. So just looking at DNS traffic, it's pretty easy to do pervasive monitoring. So I think the bigger question for IoT devices is to discover and use network provided DOT servers, and home networks and ISPs should start migrating to that, and that way they get both security and privacy.
Completely.
So as I said, I'll do a call out to the working group around all the MUD work. And Michael, you have one more, and if you could expedite, that would be fantastic.
I will go as quickly as possible. How fast can you hit the down arrow?
Fast.
Down.
All you.
Next. Device goes into quarantine because it violates its MUD process. Next slide. During that quarantine, it needs to access its updates. Okay, and the device can't update itself. It may have to be connected to critical things, and so while it's in quarantine because it's behaved poorly, we don't know exactly why yet, it may still need some network access. In particular, at the minimum, it may need network access to the update server in order to be able to get the update. If it's some other critical device, and we're thinking like, ventilators, then maybe it needs access to the status console to update the fact that it's still running, it's still working, although maybe it's done something that was maybe a bit wrong. In particular, early on in the MUD lifetime or life cycle, vendors are going to get MUD. They're going to get things wrong. They're going to not know exactly what they're doing. They're going to trip over and be quarantined unintentionally. And so we need to be able to basically continue on in some reduced access profile. And this essentially says this marks which access control lists, which ACLs are to be enabled during quarantine and which ones are not. That's it. End. Next slide. There's an example. Next slide. Next slide. I think that's it.
Hitting down. I think that's it.
Yeah, that's it.
Questions?
Not a new document. It's been around for at least a year. Hasn't changed much. There's not a lot to say, I don't think, in it. Security extensions are very long.
Michael, I mean, this seems, thanks for the draft again. I mean, this seems obvious and the right thing to do. I was wondering, I mean, why not let the device do its intended activity in addition to the firmware updates? Because, for example, for a home use case, right, you don't want the device to stop completely functioning till the firmware upgrade happens.
Yeah, I'm not saying it's only for firmware upgrading. I'm saying you can mark any ACL as being essentially critical. And so, if the device needs to do something specific, you can significantly reduce its functionality when it's been tripped.
Okay, thanks.
Okay, thank you very much, Michael. And up next we have got Andrew. Can you hear us?
Yes. Yes, I can. Can you hear me?
We can. You're coming through loud and clear. Andrew Gray, all yours.
Perfect. And I will expedite this as best I can. So this is sampled streaming. We presented this at the last IETF. Next slide, please. Just as a quick refresher, the problem we're trying to solve is essentially we as a service provider, we're seeing all these platforms with insanely high throughputs coming down the line. We have a number of devices presently that do various traffic captures and what have you. However, various vendors and what have you are informing us it's going to be a struggle to maintain sampling rates and what have you. That are going to be acceptable for our general use case. So what this draft is trying to do is make it so we can actually just have the forwarding ASICs on the boxes themselves, do the sampling and sending the packets off box in a format that is extremely convenient to those forwarding ASICs, because I can throw a ton of x86 compute or whatever I want to do to this traffic flow once I get it out of the box. In addition, that forwarding ASIC certainly has additional information, exact times of when the packets came in, especially if we combine this with PTP, which is something we're experimenting with, getting very precise data as to when the packets started coming in an ASIC and when it was starting to leave, that sort of thing. Let's actually skip all the way down to changes from O2, which is slide 8. We'll skip the rest of this. There we go. So after the presentation in Singapore, we did have another follow-up meeting, which was we got a lot of good input on that. We have done a few updates. We are using the OPSAWG GitLab or GitHub for this work, so you can find it up on there. There were some questions about what interfaces are available or subject. Some people mentioned there's a pretty good use case for doing subscriber interfaces. After talking about this, it's listed in the draft as an explicit option, but unfortunately it must be a may, because again, every platform is going to be operating differently. So we didn't want to require that in there, and that might be, probably should be a should, but that's one of the things that we're pondering about. There was a lot of questions about how this is different than PSAMP, this draft focuses primarily on getting the metadata extraction out of there with a negotiated packet header and packet format that comes off the forwarding ASIC. And its primary driving focus is to keep the control plane of any specific router completely out of the packet flow and make it so the ASIC can do it just as quick and as simply as it possibly can. There was a request to clarify the order of sampling requests. Basically, how do they get actually installed in terms of do ACLs occur before or after? This one we ended up having to split a little bit because there is an option inside sample streaming for please sample the packets that you would normally discard, which has a number of interesting use cases that have been talked about, basically verifying things like ACLs are working, or QoS filter or QoS rate sampling is working, that sort of thing. So the draft has clarified that if there is sampling requested of drop packets, it must occur before any other sampling, and if there is no such matching, it has to occur after the sampling, which seems to be the best compromise, but more than willing to take any additional feedback on that one. Next slide, please. Request from the working group. The 03 draft did get posted. However, we really could use help or a co-author or somebody to come in and help with some of the Yang model work. We did have some feedback to bring in PSAMP and some of the other work that's already been done for models. There is a little bit of overlap. We made a crack at it. It's not great as of 03, so fully intending an 04, but certainly wouldn't mind having another or a few extra sets of eyes on specifically the Yang model in particular, and if any other people want to have any other kind of feedback about the draft in its entirety. And that is actually it for me. Any questions?
Michael Richardson is in queue.
Okay.
Hi. So this is sort of fortuitous in the sense that one of the piece of work that's not on our agenda this time is to restart the PCAP-NG work. So I just wanted to say that maybe there's some good synergies here between this document and PCAP-NG. There's a bunch of different ways that I can imagine it, some of which may be not necessarily changing your wire format either. Thanks.
Yeah, so this draft is actually, one of the tricks to it is it's a dynamic wire format, because it's done that way to allow the box that is actually sending the traffic to say, hey, this, my forwarding ASIC or whatever has this little bit of metadata, these 10 bits or 12 bits or 4 bytes or whatever it ends up being in the header. I can send that off to you. Here's the format. The encoding of that or the how that format is described is actually flexible enough that you can actually, I think I actually have it in their draft as an example, say here's PCAP-NG's form or PCAP's format. And just
I actually thinking about the other way. PCAP-NG could actually standardize all of the different captures from the different ASICs that you may imagine as well. So you could write it to a file in that format and have it stamped as being that format on Wireshark, and then open it natively for coming from where it's coming from your chip.
That's actually, okay. Yeah, I'll have to take a look at it. We've been using a variety of little shell-based tools to try and tinker with this here locally, but yeah, that would be, that's a good suggestion. Okay, I'll take a look.
Run.
I kind of have the similar question and suggestion as Michael, and I think eventually you want to export the raw packet with some metadata. So why not extend some existing protocols like IPFix as the exporting channel, or I see some existing span protocols like YARSpan and so on.
Yeah, so again, because the primary reason behind this is intended for a forwarding ASIC to do. We need to be able to allow it to be as simple or as relatively complex as those ASICs can handle. You know, the newest ASICs from Cisco or whoever else can do some fairly complicated things. You know, if we're talking lower end hardware, you know, you may just get the raw packet and basically nothing else, no metadata at all. So having the flexibility to be able to carry that metadata and get it off the box, it is intended that this gets sent to a collector box that takes that metadata, then hashes it, well, hash is a bad word, then reworks it into another format then to be sent on or be a collector in and of itself. So this is just to get it off the box as quick and easily as possible, without needing to involve the control plane, without needing to involve any additional overhead on the box.
I did not really implement all these protocols, but it seems the IPFix could be implemented also in ASIC or hardware, and I see the span protocol is to monitor to mirror the interface, so it should be very fast. I think it could work for this requirement. I think so.
Yeah, so we talk about this a little bit in the draft as to why it's not a great fit. In terms of RSPAN and ERSPAN, those are also fixed protocols, so we may be able to get the data we want. We may not be able to get the data off. It may have to involve a variety of packet reordering and rewriting of headers and what have you, which is all of which we're trying to avoid. That's kind of the root of this. I'll take another look at the RSPAN and ERSPAN stuff and see if there's a way to do it, but having the ability to specify the packet format coming off the box is kind of the key bit to this. So anything that tries to put wrappers around that is going to be against what we're trying to do, and potentially makes it so less capable ASICs cannot do it. And that's the other part of this is, yes, top tier ASICs can do a lot of really amazing things with the packets going out of them, but we don't have those everywhere in our, at least in our network, and can't really afford that. So we need something that even the most basic ASIC can go, hey, you know, I can only give you, 8 bits to tell you what port it came in, but at least here's the packet. And that's all I can do. Okay. And that's the main concern with those.
So I have a chair question, but I'll let Frank jump ahead of me.
Thanks, Joe. One quick one, and I think I asked that question in somewhat in a similar format in 106, and also sent a note to the email list. This is the same vein of what we heard so far, Andrew, and I think it would make sense to include an IPFix example. So you have suggested packet formats in section 4. And it would be, I think, useful for all the IPFix-minded audience to go into a similar example with reference to IPFix-defined fields. And because the delta between what you have in the example and what you could go and do with standard IPFix fields is relatively small. And I think that's also what Jenner was hinting at. So I think that example would help everybody understand things much more rather than raising the obvious question over and over again. So I think that little section would probably help readability and understanding much more than coming back to that argument and that question all the time.
Yeah. All right. I'll make a note to put that in there. And then the other part that came out of that same conversation, I think you and I had at Singapore, about pulling in some of the IPFix fields for doing the on the negotiation to say, hey, here's the different formats and whatever. We did pull some of that into the Yang models. That's also part of the other thing. We kind of need to go back through the Yang models to clean that up a little bit for an 04 draft. All right.
Andrew, real quick, I haven't looked at the latest model. Is it in a place where you wouldn't mind a expert Yang doctor review, or are you really just looking for a co-author to really shore it up first?
I think actually we're kind of in an almost state with the Yang doctor. I think let me get an 04 kicked out first before the Yang doctor review, just because there are a few things in there that I do want to have enough time to go back through. But I think at that point, yeah, having a Yang doctor review would be very beneficial, because a lot of this is wrapped up in the Yang model, and most of it is in pretty good shape. There's just one or two rough points that I know about that I want to clean up before we do that.
Okay. Thank you very much.
Thank you.
Moving right along, we have can you hear us?
I can hear you. Can you hear me?
We can. Take it away.
Okay. Next slide, please. Okay. Since IETF 106, we start the adoption call for this draft, and we received a lot of comments, suggestions, and critics from numerous reviewers. We'd like to give special thanks to Frank, Al, Alan, Warren, Alex, and Daniel. Maybe we missed some names here. Based on their feedbacks, we have updates this drafts for multiple versions. Now it's already -11. And in these revisions, we made some significant modifications on the content. And first, we clarified the scope and also the relationship of this document with some other documents. And we just highlight high-level framework and remove many of the unnecessary terms to keep it abstract. And also, we modify the framework by removing the encapsulation and the tunneling module from the framework itself, because we think that's more on the interface and the standard side. Note the one integral part of the framework itself. And we also add a lot of block diagrams and detailed descriptions for each existing framework module. And we enhance the standard status and gap analysis. And then finally, we also update the style of the writing to remove some of the marketing song terms. Next. Next, I can see the slides update. Okay. So first of all, we consider the focus of this framework is actually on a special type of data plane telemetry technologies. We categorize that as a hybrid type of the data plane OAM. And further, we can partition this hybrid type to two subtypes. One of them is named passport type, another is a postcard type. We already seen a lot of examples, example techniques in IETF for each of these subtypes. So next slide. Okay, so based on how we will apply this type of techniques on the networks, especially for the carrier networks, we come up with this abstract framework, and now it contains four key components covering the technique selection and the flow, package selection, and data selection, and how we will output the data and how we will generate the data. So for each components, we provide a detailed description and what modules we can be used to contribute to that specific components. Next slide. So why we will have this document? So because this is the only document now, we cover a new type of data plane telemetry techniques from the high level view. And we also put it in the perspective of the entire network telemetry framework. And in this document, we summarize some key deployment requirements and challenges, especially in carrier networks. And this high-level architecture framework also aimed to address some of the key challenges. And it helped to identify gaps and give the directions for related standard development. But in this document, we will not cover any standardization of underlying techniques and interfaces that will be covered by the individual drafts. Next slide. So to summarize, the main contribution of this draft is we first summarize and clarify a new type of techniques and provide the challenges and requirements for deployment. We give a high-level framework and the application example. And finally, we give the standard status and gap analysis. So we'd like to ask all our reviewers to give another round of review of this document and provide us feedback to see if your questions has been answered, or if you have any other concerns or suggestions to keep improving this document. And based on the feedback, we'd like to ask for the working group adoption for this. Thank you very much.
Frank, I see you in the queue. Frank Brockmers.
So yeah, thanks for the update, and I appreciate the effort to actually try to reflect some of the comments that we gave you. Unfortunately, I think I have to say that I'm not sure whether we're moving forward or we're rather moving backwards on the document, because I think still a lot of the issues that we identified are still there, right? So you still have a lot of terms that you define, and these terms are unclear of what to do with them. So I think you went from IFID head nodes to now head nodes, and you went from IFID end nodes to end nodes, but those are still undefined. You had IFID nodes, now they're called capable nodes. We still don't know what a capable node is, right? And you still have Huawei marketing language in there, like IFID even as the name. You have things like smart flow telemetry or smart data export. You even had that on the earlier slide. I think it was slide 3. So I think many of the comments that we gave are not even reflected so far. So not sure whether we're actually making progress on the document.
Yeah, I would see some of the terms like the head node and end node, I said, is easily understand because I said just use describes what's in the scope of this FIT-based network, and so I can add some more descriptions on that, but I don't think it will make it more clearer because I think it's basically easy to understand. And for some other terms, I can maybe, yeah, we can think of to modify the how we call that, and we can use some more neutral terms. But yeah, I think that's doable.
Zhenbin Li.
Okay, I have a question for the Frank. Why do you think IFIT belong to Huawei? Because from our point of view, because this is the inflow, this is the monitoring, I think we need a framework name. But we, at the beginning, we do not have this the appropriate name, so that we use the IFIT. But when that's the proposal, that we reuse the name in the Huawei's solution. But I don't think the IFIT is the Huawei's private name, because this is a technical terminology.
And just call it something else, right? Give it a new name. So that resolves the overall confusion, right? So either call it Huawei's IFIT and make it.
I think this is
just have it a different name. I think that's the problem that you have throughout the document. You're starting to redefine a load of terminology that is already defined in other places. And I can give you more examples on that, but I think let's take that off to the list. I think that's much easier.
No, Frank, yeah, I'd like to clarify. There's no. We try to highlight a new type of techniques. There's no terms for this. That's why we come up with this term. Right? It's very clear to show in the first slides how we categorize this technique and give it a name. And if we have a new framework, we have to give it a name. So that's neutral.
Well, I would disagree, right? IFIT supports two basic on-path telemetry modes. Passport mode, which is direct reference to IOAM tracing, and another mode that is called postcard mode, which is reference to a now deferred and no longer forward evolved document in IPPM, which is the same functionality as IOM direct export. So I think, why do we need to go and even redefine a new name for what you call on-path telemetry? We have a name for that. It's in situ OAM. I think it's well established. So I'm not understanding why we need to go and define a raft of new technology, terminology that confuses everybody without adding any value. So think of that.
I don't think that's a confusion. If you look at the slides, there's some IOM techniques covered by these two type of subtypes, but there are also other type of techniques. It's all on the data plane of the telemetry, and there's no name to cover that. And besides, that's the on-path telemetry is the name of the technique itself, but IFIT is the name of the framework. It's a different thing.
I would agree that taking this to the list, we're not going to solve this here. And we do need to move on. And I agree that taking this conversation to the list is probably the best thing. There's clearly some issues to sort out in all of this. Tianren, anything quickly? Yes, no? Tianren?
I think we need to firstly agree on the scope in the mailing list. And here I would like to add some clarification about this work. It seems it's not just a classification of the data plane technologies. It's more about the high-level framework for how to orchestrate different technologies.
Again, let's take the conversation there. We're not going to solve this on these points on this call. Benoit, I notice you're here. You asked me if I could present, but you're here. Do you want to present this? Okay, he's still on mute, so I'm gonna, in the interest of time, Benoit has asked me to present on his behalf. I hope you feel better soon, Benoit. This was presented services. The service assurance for intent-based networking was presented at IETF 106. This is an update. Just as a summary, the purpose of this work is to be able to say that given a service, let's say a VPN service, confirm that, okay, it may be configured, but is it operating correctly? And when it's not operating correctly, can we identify where in the service hierarchy and the whole end-to-end service that problem is happening? The idea here being is, it says closed loop automation on the slide. The point is, it's a way of saying, if I'm going to be monitoring something and I need to make quick corrective changes to the network based on what I'm monitoring, can I do that? Can I have enough atomic insight into what's happening with the service to be able to make those changes? The goal of this work is to provide that, to provide a way of decomposing a complex service into these smaller parts so that we can measure their health. And we could say this part of the service, or what we call a subservice, is working correctly or not, and then we can float that or surface that up so that we're able to make decisions based on that. Look at the overall health of the service, decide if it's degraded or not, and then drill in to figure out where the root cause might be. Ultimately, this is a complement to end-to-end synthetic testing, like being able to do probes over top of a service to ensure that it is functioning correctly. This complements that to be able to, again, figure out where in that service graph there might be a problem. So here's a graphical depiction of that. You might have a tunnel, the thing that you sell, the thing that you care about. And that gets decomposed, or there's instances of that. So you might have n number of customers doing it with that generic quote unquote tunnel service. There's multiple instances, and within each of those instances, there are multiple sub-services that independently need to be monitored and also need to, they have relations with themselves. So we need to understand how the sub-services relate to each other, so that we can understand from a cascade standpoint where something is failing and what impact that could have to other parts of the service as a whole, or other parts of either the service instance or the service as a whole. So we have, from the bottom up, we have these impacting dependencies, and we might also have informational dependencies with things that are related to the service but not directly in the critical path. Like, for example, ECMP, we could lose a leg, for example, and still have the service operating correctly, but it still might be degraded because that service is not as redundant or not as highly available as it could be. So what we want to know when a service degrades, what is the root cause, what is that subservice that is having the problem, and what is, if that one subservice could be shared across multiple instances, so what is the overall impact to the network or to the services that we're offering as a whole. The definition here, and this is Benoit has running and working code, working with some operators as well on this. The architecture defined is both flexible and limited in scope. So what this work defines is Yang interfaces between some of these components, how the internals of these components are architected, deployed. Those are implementation. Those are explicitly left out of scope, but the scope is how do we convey the service kind of definition, how we break down the subservices. That part is also extensible, and then the kind of the information we're getting. So you can see this is the architecture. There's questions that could be answered based on how one wants to implement this. So some of these things might be implemented on box. Some of these things might be implemented distributedly or distributed throughout the network. Some of these things could be implemented within the device, within the control management plane of the device itself. The interfaces are being defined here. That's the work that Benoit is put forth as Yang models. However, like I mentioned, the internal architecture of the SANE orchestra, service assurance for intent-based networking, the name they've come up with, that is out of scope. That is left to implementation decisions. So you can see some of the tree that's defined, how they define the dependency relationship between a service and the sub-services that require it. And then you see how those things are scored in terms of a health score that you can say, okay, either this thing is fully dead, it is degraded, it is fully healthy. And so then based on that and weighing that and measuring that across all the sub-services, you can determine to focus, what services are truly degraded, where you need to focus your root cause analysis work, or that closed loop, where your action in that closed loop can take effect. In terms of changes between what was presented at 106, there was a notion that there needed to be the idea of reflecting a maintenance window, and so they added that, being a Boolean to say whether or not a service or subservice is under maintenance, and then who is the content of that maintenance work. There's also, as I mentioned, the ability to extend the extend the model, extend the architecture to allow for new subservice types, even vendor-specific subservice types that actually have additional parameters that need to be specified. So the model and the way it's defined allows for that extensibility. Ultimately, and again, I'm presenting by proxy, Benoit wants to know, is this, and he asked this last time, is this a valid problem for the industry to solve? And there was some feedback on the list, suggestions about direction, as well as perhaps this is a valid problem. Is it a valid problem to solve at the IETF? And if so, are they going in the right direction? And we can, as I mentioned, since we can't do hums or anything here, we can take this additional requests up on the list. But I do see there are some questions in queue, and I think Sue Hares has the first one. I'll do my best to answer by proxy.
It's a simple one. Listed ISIS as a tunnel protocol in your slide, and I don't know, is that something that's part of the definition or if it's part of the main focus? There is still BGP tag tunnels. Is that something that's going to be part of this as well?
So this is an example of a service, and in this particular instance, the routing protocol, for example, is ISIS. The underlying routing protocol could be very different from this. As you decompose a service, you might find that it's BGP or OSPF. This was just an example to say in this particular case, this is a graphical depiction of how a service might be broken down to its underlying subservices.
So in this graphical example, you gave ISIS as an example, you could give BGP as an example. This is a part of the specification, which is not part of the main, but part of things that could be defined. Did I understand what you just said?
Correct. It is not part of the It is not part of the specification in and of itself. These are types of subservices that are fairly generic. As you can see, you could specify the type of subservice, but there's nothing ISIS specific or BGP specific in here. This is designed to be flexible, in my understanding, to accommodate whatever the routing protocol might be for a given overall service.
Thank you very much.
Warren, I see you in the queue as well. Warren Kumari. Okay, Warren, we can't hear you. So unless you, as I move my mouse to end this presentation, you come in, we will move on to our last presentation, which is Joey. Sorry, Warren. Joey Boyd.
Are you able to speak? Okay, let's continue.
Joey, can you hear us?
Yes, can you hear me?
We can.
Okay, so this presentation is regarding some new Yang data models for IPFix, PSAMP, and bulk data export. As mentioned, this is started as an AD sponsored draft, and we'll go through some of the summary of where we are and see where we might want to go. So next slide, please. A little intro. In the broadband access market, we have requirements for using IPFix for transporting bulk data. Bulk data collection, in this sense, is an automated collection of data from a device. It's packaged together and delivered to an IPFix collector. It goes beyond packet sampling. For example, it can include statistics for interfaces, sub-interfaces, commonly performance monitoring, things like that. There's also requirements for using IPFix in broadband forum for transporting bulk data. For example, in TR-352, interchannel transport protocol uses IPFix to transport dynamic data, for example, lease information across participating NG-PON2 systems. Next slide, please. We analyzed the existing IPFix PSAMP model that was defined in RFC 6728. We noted that it's a single Yang module that performs PSAMP operations. The collection process from PSAMP and the IPFix exporting process are all combined in the same module. It only supports a PSAMP meter and some assumptions that the device supports SCTP. And so using this model was going to be a little challenging for the other applications, such as the TR352 ICTP. Noted that RFC 5153 requires support for SCTP for PSAMP. So the model was written so that there was no specific feature defined for SCTP to make it explicitly optional. For TR352, it's only support for TCP and TLS. The 6728 model requires PSAMP meter to be configured, even if the observation point's already defined by other Yang models. There are also some other general challenges. The draft has a few more of these spelled out, but one of the first ones we noted was interface references are through IFMIB, IFINDEX, rather than using IETF interface references. The same on the hardware side, using physical entity indexes instead of using hardware component references. Of course, those didn't exist when this draft was written, so that's understandable. So our conclusion was trying to augment, and in some cases deviate, the existing 6728 model to support not only BBF requirements, but general broadband access requirements was going to be challenging. So we decided to go down a path of a new Yang model where functionality is separated into different modules so that the functions can be independently leveraged. Next slide, please. So our new model, we're adhering to the general principles defined in 6728 with some exceptions. We went ahead and adopted to conform to the latest RFC 8407 Yang guidelines. For example, identifier naming conventions, and so that makes this not backward compatible with the previous. There are also other reasons we'll talk about. We added support for RFC 8343, 8348 for interface and hardware references, respectively. We broke the model up into 3 modules. IETF IPFix defines the IPFix collector and exporter functions. IETF PSAMP defines the PSAMP functions for configuring a device to sample, meter a subset of packets from the network. And IETF bulk data export, which defines the bulk data, IPFix templates, and filtering functions to apply to bulk data. This is outside the PSAMP. SCTP data nodes that are not made explicitly optional with an SCTP feature. That way, applications not required to support SCTP can advertise as such. IPFix transport sessions allow the session information to be retrieved individually. Before, it was just a keyless list. When you have applications such as NG-PON2, which may have a large number of transport sessions, being able to pull one individually is an advantage. We've done some refactoring and made things like source and destination address types, made them choice statements so that we can have extensibility of the model as future applications come in. Next slide, please. So the idea, once you have this, is that applications using this would be expected to only need to use an applicable Yang model. So if you have a PSAMP application, you only need the IPFix and PSAMP modules. If you have bulk data, you need IPFix and bulk data export. For TR352 ICTP, you only need the IETF IPFix module. Next slide, please. So the question we're here asking is, should this move forward? We've gotten through the process far enough that we've had a Yang doctor review with favorable feedback, and we've addressed the issues identified. There were other review comments from other ADs and those on the last call review, and we've addressed those except for, and the reason we're here today is the obsolescence of RFC 6728. Of course, we chose not to augment it to support these new requirements. New models designed to be flexible. It's adhering to the latest Yang recommendations, covers existing PSAMP use case, as well as new bulk data use cases. And so for this reason, the new model was recommending obsolescence of 6728, but there are other options that I'll talk about in a second. And so should the document move forward in its present state? If the obsolescence path is acceptable, can we continue forward with it? Otherwise, another option would be to rewrite the draft to define the new models as described. And we would only then reference 6728 where applicable, describe the new functionality. And I believe when we were going through this, we found a few places in 6728 where some of the process descriptions were missing some information. So we could use this as an opportunity to fill in those gaps. And with that, that's the end of my presentation.
Thanks, Joey. So just putting it out, one of the reasons that we brought this here was it was AD sponsored, and we wanted more eyes because of the obsolete path. We wanted more eyes on this. I don't know how many on this call have had a chance to read it. ADs have any? Warren's back in queue. So Warren, comments. Hopefully we can hear you now.
My audio works this time?
Yes,
anyone?
It does.
So yeah, just want to mention this was
Warren
originally AD sponsored. I took it over, and I think it should either belong in the OPSAWG working group or possibly Rob can take it over. But I was mainly just holding it as an interim measure. Not sure if that changes anything.
Rob Wilton.
This is Rob. So my preference would be at this stage for this to go through the OPSAWG working group if there's sufficient support for doing it. Getting more reviews and eyes on it is definitely a good thing to do.
Okay. I agree. I mean, that Warren, back to you. Cannot hear you, Warren. Do what you did last time. Yes, now.
Weird. Just saying that if it does go through OPSAWG, possibly we can expedite it. But obsoleting a document seems like it should be a working group action if possible. The document, from my reading, seems not crazy. And so if it does go through OPSAWG, it should be relatively quickly, I think. But that's just from an initial read.
Yeah, I would agree that I think it should go through OPSAWG, and we'll submit it out there to the working group to see if there's interest in adopting and moving this forward. And like Joey presented, it's got a lot of reviews already. A lot of comments have been addressed, and the authors feel that it's in good shape. So we'll put that out there for the working group. Other comments or questions on the? Oh.
Is this an AD sponsored document, or it's going to be adopted by OPSAWG?
Currently, it's AD sponsored. It was AD sponsored by Ignis. It went through some directorate reviews, and there was a comment that it probably needs more eyes on from people who are from PSAMP, former PSAMP, that could give more of a technical once over on this. And then there was the question of this obsolescence, which, as Warren pointed out, is probably something that shouldn't just be AD sponsored, but should go through some working group due diligence. So right now it sits with Warren.
So it's still AD sponsor.
So it's still with Warren right now, as what Warren said, but Rob is going to be the new person, and we can put it up to see if the working group wants it or if it's going to continue on the AD route. I think that's the comments that's happened here.
Yes, just to echo what Joe's said here effectively, that I think that if we can get to go through the working group, I think that's the best choice. I do think that this work is sensible, and I don't sort of have any fundamental issue with obsoleting 6728. I'm not that familiar with it, but I do see that we want to get Yang models right, and it's okay over time if they've not been quite right, certainly the early ones, to actually update them, fix them. So I think that's all fine. If we can get this through the working group to get extra eyes on it, that would be great. If that's not an option or that doesn't work, then I could potentially look at AD sponsoring it. But if we can get this through the working group, that's definitely my preferred choice. And I don't see any reason why that has to necessarily be a long process. I think we could potentially move fairly quickly. So I'm not saying this needs to go back to scratch, but just that getting it through the working group will be a better path.
Questions or comments? All right, Xi and Thomas, I'm sorry, we've eaten well into we've only got 10 minutes left for ops area. So I hand it over to, first I'll say that if ops area wants to defer any time they can, but if not, Xi and Thomas, you have first dibs for slots in IETF 108 for ops area working group. And with that, I will hand it over to you, Rob and Warren, for your remaining sort of 9 minutes.
Okay, awesome. Thank you. Hopefully my audio is working. So first off, thanks everyone and welcome to the ops area part of the joint OPSAWG and ops area. I'd like to first start off by thanking Ignis for his service and also say I'm really excited to have Rob Wilton serving as our new ops and management AD. I'm sure everyone will make him feel welcome. And Rob, for those who don't already know you, I guess could you take a minute or two and introduce yourself and tell us a little bit about yourself?
Sure. So for those that don't know me, I've not been participating at IETF for that long, so it might be possible that some of you don't. I've spent over 20 years working for Cisco, more recently directly and before that indirectly as a software engineer in their service provider business unit. So my background is on the service provider OS across multiple platforms and things. Predominantly in my early years was on layer 2 technologies, VLANs and Ethernet. But given the amount of time I've been working for Cisco and the service provider, I have quite a wide background knowledge across service provider OS and the software stack there. More recently, I've been focused on manageability issues in Yang, particularly in IETF and general system issues as well. In terms of the IETF stuff, I've been contributing for about the last 5 years or so, focusing predominantly on Yang and the related protocols. The NMDA architecture was one of the things I was heavily involved in. Then more recently, the Yang versioning work. In terms of where I see me as a management AD going and the stuff that I seem most interested in is I'd like to try and see IETF try and finish the device level Yang modules. I think that would be good. I have particular interest in the sort of service and network Yang models and how those map down to the device level Yang models. I also have an interest in understanding what the relationship between, say, the service level Yang models or service level models being produced by like MEF and how they map onto device models and network-wide models. I also have an interest in the lifecycle monitoring and automation again. So all this stuff to do with actually monitoring how these networks are running and be able to find issues and fix them. Again, I have a keen interest in that area. So that sort of summarizes my background fairly simply, and the stuff that I have at the moment particularly interest in the next year or so.
Awesome. Well, thank you. So I think that this officially takes us into the ops area open mic time. And if we don't have any, we might be able to give a few minutes back to OPSAWG. I'm not sure if they can fit another presentation in or not really in the last 5 minutes. Anyone have open mic questions for us? Doesn't look like it. So Of course, people can always email ops-ads@ietf.org if you want to reach us. And Joe, I'm not sure if you'd like to try and fit another presentation in the last 6 minutes, or if there isn't really time.
Well, we slotted G. I'll leave it to you. You're first in queue. Can you finish in 5? Ji Yang, can you hear us? He's muted now. Maybe it's best we adjourn here, and G, you can be first. Like I said, you'll have first dibs at a Kraken 108, followed by Tom Graff, who also submitted after the line had been cut. So I think, Warren, if you want to close us, we can
Awesome.
we can catch back up hopefully in Madrid.
Awesome. Thank you very much, everyone. Thank you for showing up, and I know the times were difficult for some sort of people. Thank you for staying up late or getting up early, and we will see you all at the next one of these. Thank you very much. Bye-bye.
Thank you all.
Everyone.